Welcome to the UEFI webinar. We will begin here shortly. Hello there, and welcome to the UEFI Forum webinar, UEFI Vulnerabilities as CERT CC, hosted by the UEFI Forum. Our presenter today is Vijay Sarvepalli, a principal architect at CERT Threat Analysis SEI of Carnegie Mellon University. I will now turn it over to Vijay to begin his presentation.
Hello, morning or good evening, depending on where you're joining from. Welcome to this talk. We'll be walking through this whole idea of how CERT CC works with UEFI vulnerabilities as we handle them. The agenda goes through us, first of all, introducing CERT CC, our vulnerability coordination roles, and our specific focus recently on systemic vulnerability and the unique challenges we see with UEFI, how it became a systemic vulnerability area of focus for us, and what are the challenges in handling these vulnerabilities. And finally, we'll finish with the call to action. I'm hoping to give quite a bit of time there for me to talk through what we see are good actions that you can take so it's practical for you. If you're not familiar with UEFI, hopefully there'll be one short slide in which I'll just get you familiar with that as well. But for most of you, UEFI should be familiar. Hopefully, the rest of the other talk that you're not familiar with will be caught up with. Yeah, the Software Engineering Institute, which is a nonprofit United States federally funded research development corporation, is where CERT CC is located. The news release I put out there on the left is really the news release from 1988 when DARPA put out a notice saying we need to do something about computer emergency response. We need to set up some way for us to coordinate things like the Morris worm incident. You can go and read history on it if you're interested. And CERT CC was created in Carnegie Mellon University's SCI, FFRDC, to basically coordinate vulnerabilities and almost focused on the vulnerabilities as incidents initially. So from that really focus of incidents, as we got phone calls and different ways of handling vulnerabilities that we were noticing, the focus, the next area of focus became that many of these vulnerabilities that were being exploited or abused, or the incidents that we saw, had to do with a trend in products that actually were the sources of the vulnerability. The vulnerability coordination slowly took a shift to focus on the source of the vulnerability, outreaching to vendors and fixing the very source of the vulnerability itself, which is becoming security incidents. And the CERT CC, for this purpose of reaching out to vendors, we started working on something we called Coordinated Vulnerability Disclosure Guide to help in a collaborative way between security reporters who find vulnerabilities and vendors to resolve security issues at the product level, which can impact multiple implementations, multiple locations, multiple places where this vulnerability could be present. So CERT CC mostly depends on discovery of vulnerability done by independent security researchers. They can come and submit their report. We'll try to reach out to vendors, help them get the information into the hands of the vendors and into the hands of the right people if there is anybody in between the vendor and us, we try to reach them as well. And we also do our own research to find vulnerabilities and try to focus on how we can resolve vulnerabilities in a timely fashion. And CERT, to say, is funded by the US government. The recent work that we've been focused on is what we call systemic vulnerabilities, and related to that is the supply chain concerns. So CERT is funded by the US government. The part that funds us is actually CISA, DHS CISA, Cyber Information Security Agency is the one that actually funds our work. And CERT actually has been trying to focus on not just vulnerabilities, on the specific trends of vulnerabilities we see, what we call systemic vulnerabilities, and try to resolve them. I'll explain to you how that focus came about and what the details of that focus is. CERT can actually do this by doing a number of different things, like we can play an active role in what we call multi-vendor coordination. Those terms will become clear to you as you go through it. We can act as a clearinghouse. If you read about the US government executive order 14028, you will learn about US government's focus on trying to resolve vulnerabilities and supply chain concerns in software. And we actually, in a way, act to reach out to multiple vendors and try to resolve issues when a vulnerability involves more than one vendor, more than one supplier, and sometimes multiple implementations as well. So what does this coordination vulnerability disclosure actually look like? What is the process? What happens? These terms may be unfamiliar to you if you're from a software background but have not specifically done coordinated vulnerability disclosure. Even if you've done security or cybersecurity, this may still be unfamiliar to you. So I'll try to spend a little bit of time explaining these things to you. So the coordinated vulnerability disclosure, the whole idea is any security researcher who finds a vulnerability and wants to report it basically can submit those reports to a third party called the Coordination Center, or the CERT Coordination Center is one of them. And once that vulnerability report is validated, understood, and triaged, and the sources of the vulnerability are identified, say the vendors, the products, the open source products, or multiple implementations that are impacted. So the reporter is the one who kicks off this work. He's the one, the stages we call starts from discovery, where the reporter actually discovers the vulnerability and he reports it to us. We validate and we triage to find out how many vendors or a single vendor is impacted. We try to get involved with the vendor in submitting the report and try to find ways they can remediate it. And the final two steps are also very important. We try to raise public awareness of this, because a vulnerability that's never disclosed, the very last word in the CVD process, is never understood or never resolved, never fixed. Because many operational environments never update a vulnerability unless there's awareness, first of all, of it, and also a reason for them to fix it. Then we try to track a little bit of the deployment. So the actors in this play, so to speak, would be the reporter who initiates the work. He carries on the work till he gets some recognition for his own work. At the public awareness, he's involved trying to do different things at different stages, first discovering, where he's maybe reverse engineering, researching and trying to find vulnerabilities, and then reporting. And if the reports are good, he's able to basically submit it to a coordination center like ours. And we validate, triage, we start picking up from that time. And we collaborate now at that middle stage where the three big pillars, we basically interact between the reporter and the vendor, acting as a third party, trying to communicate without bias the information that the reporter has that he wants to make public. And we're giving the vendor enough time to resolve the problem before it goes public. And that is the embargo time you see at the bottom. These terms may be also new to you, so I'm trying to make you familiar with them, that way you know what the CVD process looks like. And the vendors can fix the vulnerability, try to get their information out. They can publish also if they like to, or we can publish if it's an interesting enough vulnerability and we'd like to put out a call for action for public awareness of it. The deployers are typically operational environments that pick up these things like CVE reports and start basically implementing fixes. And I'll cover a little bit on these extra arrows we have, like this little purple arrow on the coordinator, where the coordinator themselves, like CERT Coordination Center, can do our own discovery sometimes. And sometimes we go all the way to deployment to measure and see how good this vulnerability is. I'll cover this a little bit more and talk about systemic vulnerability. The vendors at some time come to us when they actually discover a vulnerability, but they realize they have multiple other vendors who are impacted, but they may not have a consistent way to communicate to them, communicate to their engineering divisions. The security division might have trouble reaching them. So we can act as a helping unit to reach when one vendor finds vulnerability, discovers it, and reports it. We can reach other vendors and make it happen. And the vendor's role, like I said, also can go beyond that to supporting deployments and measuring deployments and different things like that. So overall, all these actors are very actively involved. The CVD process, as we call it, is very communication intense and very workflow oriented, with a little bit of the privacy maintenance time called the embargo time. We try to keep this information as private as possible. So the question always comes up as to what is a vulnerability that's worth following? What is a vulnerability? What is the definition of a vulnerability? There's many hundreds of definitions out there. We try to follow the NIST 828 definition as close as possible. Basically, it ends up spelling out a flaw or a weakness in a computer system which could be exploited to violate either an implicit or an explicit security policy. For security policy, we can chop this definition too much, but overall, the idea is a vulnerability is defined as something that violates a trusted operation or a trusted way a computer is expected to behave for a particular input, a particular source of data that's coming in. And this implicit explicit will become very important as we talk about UEFI, especially where it's very difficult to say what security policy is being violated, but I'll talk about that a little bit. Hopefully you'll get the idea as we give some examples of it. And the thing we found out as we handle vulnerabilities, there's thousands of them. If you follow the CVE trend, which is the MIDAS program, or the CVE program's effort to try to get unique identifiers for vulnerability, the vulnerability continues to grow. So what we started focusing on is a systemic vulnerability area. That way we can invest our time in something very important where other coordination centers may be picking up. PCERTs, which are basically product security, response teams are also picking up their own way to work on workflows. We can focus on something that's very widespread, very difficult to detect, very difficult to understand. So that's what we label as systemic vulnerability. The definition is long. I'll try to pick on few important words there. Saying it's basically an embedded flaw that's pervasive. It has multiple implementation. It's very difficult to detect, very, very complex in its dependencies. It's elusive. It's very hard to say what is the root cause of the problem. And sometimes it's tempting for vendors to assume this is just how the product works, type of response sometimes when you explain this as a vulnerability. And this is also very resistant to effective remediation, very difficult to patch, say, very prone to recurrence, meaning you can roll back and go back to a situation where the old vulnerable configuration can be restored, and the attacks against the threats can continue to evolve, right? So here's the interesting part of the UEFI. As we're researching this, we came across multiple technologies that fit the bill. This is one that seemed to have really picked up quite a bit of steam somewhere from in the late 2010 time or so as a de facto standard to replace your BIOS. BIOS is basically your early blue screen that you see when the computer boots up. And UEFI actually started defining a standard way to basically make this BIOS a much more reliable, with faster boot times, with a wider range of device support, and catch up with the growth of the hardware and the software demands, like the RAM and the storage, and a user-friendly interface instead of the old blue screen. So those are big goals of UEFI, which I want to focus on this word interoperability. This is a big term that's actually made UEFI go in a particular direction. It could be one of the opportunities for us to take advantage of that when you handle vulnerabilities as well. So the question comes back as to whether UEFI is a systemic vulnerability area. Is it really a systemic issue? There are two, at least, key things I want you to think about when you think about the systemic vulnerability from the result of a systemic vulnerability point of view instead of the definition. The result of a systemic vulnerability is this persistence, meaning an attacker is able to pursue objectives in a very long period of time. The APT is a very famous buzzword through which they talk about advanced persistent threat. The P in persistence is what this is really one of the things we found in UEFI. Persistence is very possible and very powerful. And the second very related thing almost is the invisibility. It's currently very invisible, very difficult till later in 2020 or so, 2018 and later. A lot of the APIs have been evolving to try to give you visibility into the UEFI software from the operating system to do audits, quality checks, and pedigree verification, like pedigree meaning chain of software. If there is some software, all the dependencies to it can also be audited. So what we started doing in late September of 2020 is our threat team found some very interesting attack, and I'm going to spend less time on the threat side of this because there's lots of fancy terms nowadays like fancy bear or midnight or all these different new terms to talk about the threat actors. I'm not going to focus on that as much, but the thing we found on the technology level was this attack was very well done, and the UEFI environment that they attacked was basically highly persistent. OS and EDR, stands for Endpoint Detection and Response Tools, had no way to detect even the XDRs today, including the very famous ones like Sentinel and CrowdStrike could not even see this had happened. And so we started focusing to understand and mitigate UEFI vulnerabilities to see where these vulnerabilities come from, how we can hopefully get a handle on these. And to continue the idea, UEFI became more and more clear as a very, very important systemic vulnerability area. It was prevalent in millions of computers, and it was built with many components, a big supply chain issue of multiple components, multiple open source and closed source, and different software put together. And UEFI vulnerabilities were very difficult to explain. We had a hard time even convincing some of our own high-level staff about what the problems were and how difficult was it to even find out if a vulnerability is actually present on certain systems. So we started basically doing an outreach to security researchers, vendors, OEMs, everyone who's involved in UEFI, including the UEFI forum. We started engaging with these people to understand what is being done for vulnerability. And we said the best way to understand one is to handle a case. So we ended up handling a vulnerability case in early on EDK2, which took us about 14 months to resolve. That's a very long time. Our target typically is 45 days, and this 14 months is many times longer than that. And there's multiple reasons for that. I'll talk about that more as we get to the rest of the presentation. The question also comes back, if this is so hard to explain, so hard to understand, nobody knows about it, it's hidden anyway, should we even worry about the threats? Are there people trying to attack this? Are there people trying to do anything with this? Like I said earlier, I'm going to avoid just focusing on anything like the actors or the threat actors. However, they talk about international nation-state actors who are doing this. I'm going to focus on the technical problem here. So the threat groups that we saw targeting UEFI were actually making progress, making more complex ones, making some of these ones hit at the very foundation of UEFI. The list of vulnerabilities there, you can go back and look at them later on. I'm not going to spend too much time on them, but focus on what happened since 2021. Eclipsium was one of these research organizations which hit on the boot hole, and later on it was enabled by an actor to do the trick boot. And later on, as it evolved, we saw some of these vulnerabilities remain unresolved for almost ever. Every one of the systems we try to understand if this particular vulnerability was patched or fixed, we did not find many of them to be fixed at all. Many of the implementations found it very hard to understand how to really write a software for it. And some of the high-end threat groups that are very focused on attacking something like Intel ME, which is a management engine deep inside the core of Intel, were using UEFI as a way to get to Intel ME, and that seemed like the only way to get close to hardware level vulnerabilities. And the UEFI attacks also were going after a number of supply chain vendors. People are pursuing all these different companies. They're contributing a lot of software for UEFI, and those attacks for basically getting source code from them would reveal more opportunities. The peak of this threat, I would say, was basically Black Lotus, which still remains kind of confusing, a complex problem to solve. This is really a downgrade attack from Windows sign driver through which you can actually roll back to an older version of EFI file and use it to attack the system and basically trick the system and disable or enable secure boot without any awareness of the user at all. So the UEFI vulnerabilities challenges we found, I'll try to summarize them here. The vulnerability reporting was very difficult due to a lack of understanding. We had a hard time communicating from the researcher whatever we wanted to the vendor. We also had a very difficult time really explaining the complexity of some of these attacks, where many of the OEM vendors and the whole supply chain vendors that are involved in this, we had to convince multiple of them to make them understand the problem, because the attack on one end looked like it was not possible, but till you saw a real live attack, you could see how it impacted multiple OEMs as well. And the other thing we found, UEFI software is built from other software, all the OpenSSL, all the base64 libraries. Nobody's going to rewrite those. They're going to be using all these outsourced components, and these were unpatched. These remain very, very old versions of image processing and file processing and base64 decoding. All those components are all very, very old versions that are all seen to be vulnerable. And it was very difficult to verify if a patch actually happened. We went through an audit of looking at a number of Azure systems and virtualized systems in which UEFI being implemented. It was very difficult to say if anything was patched, any of the forbidden list that blocks the bad software or vulnerable software was ever implemented. And there's also lots of vulnerabilities that seem to have been fixed here and there without any public advisory or any record. There was no transparency. So the end user at the end of the day did not even know something was fixed, and he needs to take action to implement it. So our going back to the earlier story I told you about the CVD, our CVD process is a viable way and a reliable way to do this vulnerability response better, to help understand the vulnerability early and communicate with multiple vendors, get the right information out, communicate privately, maintain this embargo time, and then release publicly so we can actually move forward the community of end users to take action and to be able to implement these fixes and call upon these vendors like the OS vendors and other OEMs who are writing software to be able to better audit this and provide better tools to fix these vulnerabilities. The open source community outreach uh, was also an important part of this, as we found out many of the vendors, the independent bias vendors, were using open source but had very little communication with them, very little understanding of how to connect to them, how to get information from them when something major happened in a vulnerability in an open source component that they may be using. So the efforts that we put on are these new boxes I put out here. So the things we started to do is engage with security research for partnership, recreate the attacks locally. We have a whole bunch of laptops now to which we walk through from multiple OEMs to recreate the attacks and try to really verify if these attacks are possible. And we started internally developing some subject matter experts for UEFI software, being able to audit it, understand it, being able to reverse engineer it, and find out a good bill of materials of UEFI software. And on the coordination, we started reaching out, doing accelerated commitment to UEFI cases, inviting people to pass on these cases to us. We reached out to vendors, the IBVs, first of all, and then started basically reaching out more and more to multiple OEMs and multiple groups of vendors that are labeled IBVs, IFVs, independent bias vendors, firmware vendors, and all these different groups of people that we showed earlier as part of the supply chain concern at the bottom here. So the other things we tried to do also is to do better detection, better understanding of how these UEFI code is present, how the efforts like Linux vendor firmware system was actually collecting capsules of the updates and was actually auditing to find out if security bugs are fixed and whether we can announce and almost make sure people understand that these fixes are important to implement. The extended outreach also, we reached out to also a lot of deployments from Department of Defense, government, and US government to find out how they're handling vulnerabilities, especially as it comes to UEFI. So these things give us more and more ability to basically span out and continue the coordination workflow a little bit greater than what we do. The typical things we do starts with reporting and then public awareness, but we stretched our efforts beyond this to try to do this more. This CERT CCCVD is designed to work with you. We try to be as systemic as possible. If we hear about things like a 0 day, as they call it, or excitement, something, we still don't panic. We try to prioritize it as best as we can, and we try to be systematic in reaching the vendors. We try to avoid all the unnecessary conflicts or confusion about a vulnerability can be exploited and can be automated and all these things. We try to be as objective as possible. As we reach vendors, we use a process called SSVC for a lot of these stuff to try to formalize the way we respond to new vulnerabilities, the way we reach vendors, the way we communicate with them, the things we try to tell them, things we try to tell the reporter, try to balance the way of getting actual facts into the hands of the right people instead of worrying about all the buzzwords and all the excitement about 0 days and other things that happen. So we started handling UEFI vulnerabilities. There's a small list of those vulnerabilities. There's a bunch more we handle from the back end. Some of these vulnerabilities we publicly announce. The ones that say publish are the ones we publicly write about because we think their impact is big. We try to do outreach to make sure we have a clear category of this vulnerability. We've been working with Binary to understand these categories that they've come up with. And we've been building our own as well to try to expand these ways to understand what these vulnerabilities are and how we can distinctly categorize, understand them, and tie them back to something like CWEs. So we clearly understand the root cause, and the patches are actually very meaningfully provided to the vendors, to the deployers, sorry. So I'll tell you a little example here of a supply chain complexity in UEFI. One of the reports we got from, I believe this was from Binary when we first got the report of a vulnerability of SMM memory corruption. We went through and reported it to Intel, and Intel had said this particular device is no longer receiving updates, it's end of life. And that was in October 2021. They confirmed it's a vulnerability, but it's an unsupported and it won't be fixed or won't be pursued to be fixed. But the thing we found out was the same vulnerability was present in multiple other OEMs, Lenovo, Star Labs as an example here, but even more, many more were impacted by this vulnerability. And about 40 different vendors had the same code. And nobody knew where the source of this code was. It made it very clear to us there's a lot of reuse of code that's prevalent across vendors, and also unaware to the vendors that they got integrated into their production. The things we find also as we communicate to UEFI vendors, we find the research vendors, like I told about the complexity of the problem, makes it possible for the vendor and researcher to disagree on a vulnerability, on something like the details of the vulnerability, the timing. Should we give credits to the finder for what he did? And the list goes on and on as to what different problems are the challenges we face as we try to communicate between the researcher and the vendor. In multi-vendor cases, most vendors like to consume the information, but they never give back anything. They never collaborate, or they never give information that supports other vendors who may be affected. When it comes to a vulnerabilities response, we try to ask the vendor whether they're affected or not affected, or they're unable to confirm if they're affected. Many vendors are very confused about the status because they think it's a liability. They're making a public statement. They think it's a PR statement they're making. It's not, none of those. It's really trying to honestly identify if a particular software has the problem that's being identified. That's all. It's got nothing to do with all these other concerns that many vendors bring up. Researchers are also confused sometimes. They think the disclosure is about amplifying their own voice, providing value by providing their own products or services on top of the current UEFI software that's there. And they sometimes not, their outcome is not a research output, a valuable research output, but ends up being more of a social media and a noise creation and stuff, a real pursuit of proper disclosure, proper closure on the software that's to be fixed. So I want to come back to identifying every advisory we put out is measured back against the purpose, systematic as possible. We focus on public awareness and public welfare. We try to reduce confusion. And duplication is a big problem. Duplication is a huge problem in UEFI, especially same vulnerability is seen in multiple implementation, and people think it's a unique implementation, therefore it's very different from the initial one, but sometimes it is, sometimes it's not. So we try to reduce all those duplication by reaching to the vendors as early as possible. We try to reduce the ambiguity of a vulnerability, if it's a vulnerability or not, and how serious the attacks can be, how serious the consequences can be. And we want to do a distributed way of information gain, meaning when we put out an advisory, we try to link to other advisories and not try to make our advisories the only source of the information. Another important thing to understand is we assume that all parties are working in honesty, in good faith, in benevolence. There is no like personal gain or any other focus of the parties that is being the focus of our work. Especially, we're trying to make sure the parties' information is as transparent, as clear and simple as possible. The last few minutes I have, I'll try to cover this whole call for collaboration from the UEFI vendors and the security product people who are actually working on this stuff. All UEFI software providers should consider a way of basically having a security point of contact, security vulnerability reporting workflow. PCERTs should consider also. CISA has put out a thing called a pledge for secure software, the secure pledge. I recommend you looking into that. That's a way for you to engage with CISA to know how to become a part of the CVD process, so you can actually get out vulnerability disclosure in a proper way into the hands of the public, as simple as easy as possible. And the UEFI chain of digital signing, consider the ways of when you digitally sign some software, you could use that also to include something like a PCERT contact as a possible extended attribute in the certificate. We've written down a little bit about these things in our public blogs. I will not go too deep into that. So consider the way of tracking your software, especially when you're digitally signing it, when you're using some way to attest it to be software that you agree is good. And the work of PCERT itself goes in a way beyond SDLC, and also as part of SDLC. SDLC is your software development lifecycle, that security in basically handling the whole software development lifecycle is important. But there's a section that people forget, which is called the deployment and maintenance. After we're talking about vulnerability management after your product is out. Many people say, oh, we already do security. We're talking about security not only at the design time, but the assumption is many of the software you put out eventually will be vulnerable, and you have a PCERT way to respond back and be able to feed back into your SDLC cycle to deploy and revive that cycle. There may be confusion about what the security stands for. We talked about security after a product is out, right? So to finish, I think I'm out of time, but I'll try to get through this very quickly. The UEFI security is critical. We believe really this attack is foothold that is both persistent and invisible. It's very attractive for attackers. So it's time for us to act and be committed to fixing this. The security goes beyond interoperability. You see UEFI doing heavy work on the interoperability side and the reliability side. And I think the things to consider beyond those two things is the CIA confidentiality, integrity, and availability parts of the security. And your security needs to go beyond these interoperability tests. And this requires outreach. You need to collaborate with your downstream and upstream. These are terms in the supply chain story, where downstream is the vendors to whom you're providing the software, or you're collecting their software. Upstream is where you're providing the software to the next supplier in the supply chain. It's important to establish the trust boundaries very early, because we're going more and more into cloud and AI-based software, and millions of these computers are going to be present, answering very complex questions, supporting things from medical to every possible logistics like airlines and everything else. So as you get closer to this chip to cloud security, this is very critical for us to basically ensure that we establish the trust boundaries. This is also important for the national and global interests. We really see this as an important part of the CCERTs and the CERTs. These are different parts of the country level organization that are involved in security disclosure as well. I'll give you these links. Hopefully there's links that are available for you. Consider the Secure by Design pledge from CISA. CISA has done an excellent job in trying to really make it possible for vendors that are very, very small to actively be involved in securing their products and having a low-cost way to get involved in the CVD process. And CISA is very involved in also trying to put out a project where they're actually evaluating vulnerabilities, putting out enriched information about vulnerabilities. We have a VINS portal to which we collect vulnerabilities. If you are a UEFI vendor of any sort, please get involved. Please see our reports and see how you can help us also reach more vendors, more ways for you to reach the vendors you might have even lost contact with. And I think I've made it through. I'm sorry I had to rush through the last few slides. Hopefully you've been able to capture all of it, but we'll spent time the last few minutes with these questions. I did see one question already. I'll read the question back to you. Software that we get reports for is already end of life. We cannot fix it. Should we consider coordinating these vulnerabilities? This is a very, very important question. If end of life products, what we should do. We work with the CVE program very closely on this problem of end of life products. The disclosure part of vulnerability still exists. Even if you don't fix the vulnerability, it's good for us to get a CVE and identify the product that's been end of life. I can give you a little bit more information on it. If you can search for CVE and end of life, you'll find a lot of information on how to really put out a disclosure information for a product that's end of life, asking your deployers all the way back to different vendors to basically upgrade to the newest software. So that's a very important thing for you to do. The disclosure still applies even if you don't get to fix the software because it's too old. It's not worth fixing it. If you have any other questions, please. Yeah, thank you for this question as well. It's another one that came in that says, how is the PCERT different from SDLC created secure software? So the PCERT, the idea of PCERT is actually from an organization called FIRST. Just spent a lot of time explaining about the role of this product security incident response teams. So the PCERT's role is distinct from SDLC and secure product creation because the SDLC process is very focused pre-delivery of a software as to how to secure it. And there's a lot of steps involved in doing the secure testing and everything else. Once the product is out, we realize it can still be vulnerable. That's where the PCERT's role is very critical. PCERT ends up being that little arm of outreach that reaches back to your SDLC team to give information about a product that's already in production, in implementation that's vulnerable. So we really get to understand how these vulnerabilities are actually revealing themselves in true production systems instead of in the early testing that you did, which may be not integrated yet to all the other things. Next question I have, do we have any live demos which shows how these attacks are happening on UEFI-based firmware? There's a number of fantastic talks. The latest one by Alon Lviv did a fantastic talk in the recent Black Hat 24, where he demoed a very, what he calls the downgrade attack against UEFI. This is a very, very practical attack by which he was able to demonstrate to this day. He can actually downgrade using some of the components of UEFI. But UEFI attack has been demonstrated many different times. Black Lotus video is a great one. It's in GitHub. There's a good demo of Black Lotus. There's even a CD demo which you can download and put it into a very simple UEFI-enabled virtual machine to test it to show how it works. It basically works with a downgrade of using an old vulnerable software, attacking that software, and that's probably a very powerful demo for you to look at. Yeah, this is another important question. What if the reporter works for a competitor or is aggressive towards the company? We try to mitigate these risks. Like I said before, our focus is on trying to be honest and as focused on the technical details of the vulnerability and avoid any of these other concerns that come in. If we see a reporter as aggressive, we've had to basically tone down either a reporter or call out a reporter. We had many challenges with this from time to time. So we have some experience in handling this problem. We try to focus exactly on the vulnerability. We try to avoid any of these other things that people bring in as part of the report. We want, finally, at the end of the day, the deployers to be aware of the vulnerability. The simplest way to fix the vulnerability instead of worrying about anything else. Yeah, so the other last question we came across, we do not sell directly to any consumer. why should we do public disclosure? Why do we need a CVE? This is also a very common question. I'm glad you guys are asking it. Instead of me kind of having to prompt you. The reason to get CVE is to uniquely identify the vulnerability. We found with many vendors that a particular product that you provide, say even a small UEFI firmware binary, ends up in 5 different products, and it goes through its own supply chain and is reported to the OEM. If we don't provide a CVE, multiple people will continue to discover this vulnerability, and they'll keep reporting it back to you. There's no way to know that you actually fixed the vulnerability or moved from version 1.0, which is vulnerable, to 1.1. There'll be no way to document that, no way to know, especially in this complex supply chain. And the public disclosure doesn't have to be your own public disclosure. Like CERT itself does public disclosure on behalf of small vendors, so we can support that way as well. CVE is a very useful way to uniquely identify and close on the vulnerability. And I think if you don't do that, you end up leaving this vulnerability open without any awareness of everybody who needs to patch this vulnerability or do anything about it. Here's a question on what is the most powerful UEFI vulnerability assessment tool. I don't think this exists today. Even the UEFI firmware parsers today are very, very weak. The UEFI vulnerability assessment is something that's still evolving. Many companies like Sentinel in their division in Israel, and Safe Secure, I believe, is another companies who've been working on a lot of this discovery tools and assessment tools to basically work against UEFI firmware. As UEFI firmware is sometimes encrypted, complex, writing a good parser and finding what is in there is hard, but it's not hard for the attacker to do this today. So there's still not very good tools to do assessment once the product is out. At this time, many of the EDRs, like I said, don't even know anything about UEFI. So all this is still evolving. But it is the standard assessment tools for your C program still are very powerful in finding vulnerabilities, and UEFI specific assessment tools do not exist today.
All right.
Yeah.
So that is going to be the time we have for questions here during the live webinar time. If you have any additional questions, we will have Microsoft Teams Q&A available for the opportunity to chat with Vijay. You can see the information here. There will also be a prompt that'll be popping up if you'd like to access the link that way. Thank you again for joining today's UEFI Forum webinar. The slides will be available on the UEFI Forum website, and the video will be available on both Bright Talk and the UEFI Forum YouTube channel. Thank you again, Vijay.
Thank you. Bye now.